Hello, algebra students. This is Mr. Becker talking. If you're watching this on A Day, it is because I am at a workshop and I'm not at school. So I've left this lesson for you via video because that's just how nice I am. If you're a B Day student, you're totally welcome to watch this video too, as you might just learn something good. Okay, so today we're talking about domain and range of problem situations. So we talked about domain and range when we introduced functions, and also with function notation. Domain, of course, is all the inputs of a function or the x values or any relation, and then range is all the outputs or y values. And domain and range have their place too in actual real life problem situations. Okay, so we're going to look at a couple of problems and talk about the equation, the domain and range, and some other things, and that will help you with your assignment that on which you will be determining the domain and range of problem situations on your own. Okay, so let's look at this first problem. I'll read the situation first. You are throwing a party for your friends. The caterer charges $60 per person. 15 guests have been invited, but you are not sure if all her friends will attend. Assume that at least one person shows up to the party. Okay, so A, we're going to write an equation to represent the situation. All right, so looking at this problem here, we can see that we have two things. We have the cost of this party and also how many people are going to come. All right. So the cost is going to be our dependent, our range value, our y, if you will. Okay. So we're going to say c equals the cost, and then we'll say that p is going to be the number of people that attend this party. And if that is the case, that means our equation is going to be the cost, or C, equals 60 times P, because it's 60 times the number of people coming. Okay? So the next thing we need to look at is the domain of this function. All right? The domain, that's going to be the x value, or in this case, the P value, which is the number of people. And that's what the domain is going to represent. And we have to talk about, is this going to be a continuous or discrete? That question also comes up in part D, but we should discuss this now when we're talking about the domain. For a party, you're either going to have one person show up, or two people, or three, right? You're not going to have any fractions. You're not going to have 1.5 people showing up unless you count someone whose legs were cut off or something. And if there's anyone out there listening whose legs were cut off, I do apologize if I offended you. So now the domain is going to be a list of numbers. So number of people, well, you could have one person or two people or three people, all the way up to 15. If we don't want to write all 15 numbers, what we can do is we can cheat a little bit and put the ellipsis marks and then just put a 15 at the end. Okay? Then find the range of the function, which is going to represent the cost. Now, the cost should represent how much it would cost for each number of people to come. So again, it's just individual prices. If one person comes, well, it's going to cost $60 because it's $60 per person. If two people come, it will be $120. If three people come, it will be $180, all the way up to if 15 people come, and 15 times 60 is $900. So 900 would be the highest value in the range. So the next question, part D, does this data represent discrete or continuous data? And explain your reasoning. Well, as you can see, since it's a list, this is definitely discrete data. So this is discrete data because only whole numbers are involved. That's one reason to disagree. There's others. Um, but again, it's mainly because you're not going to have fractions of people and or fractions of cost here. It's only individuals. Now, would it be possible for the caterer to charge you $750? Well, if it's $60 a person, 750 divided by 60 equals, I do believe it's approximately 12.5. So the answer to that would have to be a no. And the reasoning is right there, right? It would be, that was if you invited 12 and a half people, it would cost $750, but obviously you're not going to invite 12 and a half people, or 12 and a half people are not going to come to the party. All right, and that is number one. Number two, when you drive from New York to Austin, Texas, at an average, you drive from New York to Austin, Texas at an average rate of 60 miles per hour. It takes about 30 hours to complete your drive. Write an equation to represent this situation. All right, so here we have the distance going to take plus how long it's going to take. So we'll say d equals the distance that's being driven, and we'll say h is the number of hours that we've driven. So the equation would be how far you go is going to be 60 times the number of hours. If you went 1 hour, you're going to go 60 miles. If you went 2 hours, you're going to go 120 miles. Okay? All right, domain, which is going to be the number of hours. Now we have to talk again about if this is discrete or continuous. Now, when you're driving, the amount of time, the distance, does it just separate numbers, or does that increase gradually and hit every decimal in between? And in this case, it hits every fraction in between. You can drive for 1 hour, you can drive for 1.2 hours. Time gets broken up into little bitty fractions, and so does distance. So the domain of this is going to be, well, the least number of hours you're going to drive is 0, right? The greatest number of hours you're going to drive in this case should be 30, because that's what it says in the problem. So 30 is the greatest number. All right, h is the number of hours, and so what we do is we put a less than or equal to here and here. So what this means is the number of hours is going to be anywhere in between 0 and 30 hours. All right, C, find the range of this function. So the range is going to be the distance. 0 is the least amount of distance you're going to drive. And the greatest amount of distance you're going to drive is going to be 30 times 60, which would be 1800. And so this does represent continuous data. This is continuous data because time and distance can be broken into fractions. Is it possible for you to drive for 1,455 miles? Justify your answer. Yes, it is possible. It's possible because if we're driving between 0 and 1800, 1,455 is in that range. So it is possible because 1455 is between, I can't write, is between 0 and 1800. Okay, hopefully this will clear up. Any misconceptions or any confusions you might have about this assignment that you're about to work on. I will be here for tutoring Wednesday morning, or I should be, if you have any questions, or you can email me. And good luck. Thank you.